Okay, this is extension to lesson 4.2. We're going to learn about the slopes of parallel and perpendicular lines. Okay, the first key idea is about parallel lines and slopes. You noticed in your warm-up today that when you calculated the slope of two lines that were parallel, they were the same. So that will be true about all parallel lines. They will have the exact same slope. In this example, it's in your textbook. You can see the slopes of the blue, the red, and the green lines calculated for you. So we're proving these mathematically. So you have to calculate between 2 points on each line. So for the blue line, we have a slope equal to 4. The red line, it's equal to 5. And the green line is equal to 4. So since the blue and green lines are both 4, you notice that they have the same slope. They are parallel. So let's give it a try. For number 1, if I'm going to calculate the slope of the blue line, I would calculate the change in the y-coordinates. So it doesn't matter which point you start with, just make sure you're using the points. It's easy when they're color-coded like this because you know which one goes with the blue line. So I would take the change in y, which would be, I have to get a color here, 2 minus the negative 1 y-coordinates over the change in x, which would then I go back to the original point, which is negative 5 minus negative 4. And so 2 minus a negative, which is like 2 plus 1, or 3. And negative 5 minus 4, which is like negative 5 plus 4, which is negative 1. Okay? For the red line, I would calculate I could take 1 minus the negative 2, change in y-coordinate, and then the negative 2, which is the x-coordinate, minus the negative 1. 1 minus a negative 2 is 1 plus 2, or 3. Negative 2 minus a negative 1 is negative 2 plus 1, or negative 1. I can already tell that the blue and red have the same slope. So the only thing left for me to do is test the green one to see if it also has a slope of negative 3. So I would calculate the slope of the green line. 3 minus negative 1, and put that over 1 minus 2. 3 minus a negative 1 is 4. 1 minus 2 is negative 1, so you can see that it is not. So how I would summarize this and what you need to say, because it says, how do you know? You would say red and blue are parallel because they have the same slope. Okay, so if you need to pause this right now, go ahead and pause it so you can copy it down because I am going to clear this writing to give me more room for number 2. Okay, let's try number 2. So let's calculate the slope of the blue line. So again, the change in y, here's the ratio for slope. Change in y over change in x. I am doing the same for all. I'm always subtracting the coordinates. So for blue, I have 3 minus a negative 2, okay? Because those are what the integers are. I'm going to put that over negative 2 minus, and then I have a negative 5. So that's why I use these parentheses, so that I don't accidentally forget that negative. Because dealing with the double negative in the middle, we have to understand that anytime you're subtracting, you're changing it to integer addition and adding the opposite of the next number. You may recall it as boom, boom. So if you want to go ahead and change those, you change those, okay? So 3 plus 2 is 5. Negative 2 plus 5 is 3. If I'm doing the red line, I would have 2 minus, and then it's negative 2, and that's the y-coordinates, and then 1 minus a negative 2 for the x-coordinates. So you can change it with your changing it to adding the opposite. So 2 plus 2 is 4, and 1 plus 2 is 3. We know that blue and red are not parallel because they do not have the same slope. So let's check green. It doesn't matter which point you start with, so I'll go ahead and start with -3. -3 minus 1, and then I go back to that ordered pair at the bottom and do 1 minus 4. Again, you can change this to adding the opposite. Add the opposite. So -3 plus -1 is -4. 1 plus -4, now I have different signs. I'm subtracting and I'm keeping the one with the higher absolute value. So I have -3. A negative divided by a negative is always a positive, so I simply can get rid of the signs. Now I can see that 4/3, which is green, equals 4/3, which is red, and so in this case, the red and green are parallel. And the reason is because they have the same slope. The next example we're going to do now is we're going to determine if the lines that you see are parallel. So the answer to our question would be yes or no. Then we're going to explain the reasoning. So we have to remember what it looks like when we have a line that equals y equals -5 and y equals 3. So we don't have like an equation or a graph to work with. But I know that y equals -5 is a horizontal line. I know y is equal to 3 is a horizontal line. So I put the graph on the bottom so that if I wanted to do maybe just 3 different colors of graphing. If y is equal to -5, start at the origin, go down to -5, and then you can kind of make a line that is horizontal at -5. For y equals 3, starting at the origin, you could count up 3, put a point down, and then maybe put a couple other points down, and then draw another horizontal line. Would these two horizontal lines technically be parallel? The answer is yes, they would be parallel. The reason why? They are horizontal. Okay, I'll switch colors and we'll keep the other ones on the graph, and I'll switch to red. If we have y is equal to 0, so if y is equal to 0, it's literally y is equal to 0 is a horizontal line right here. I need a little eraser. Okay, and then we have x is equal to 0, which is a vertical line right here. Are the red lines horizontal? The answer is no. I think the question is, are they parallel? No, one is horizontal and one is vertical, so they cross. Okay, now moving on to question 5. For x is equal to -4 and x is equal to 1, hopefully you're getting used to seeing that these are vertical lines. Two vertical lines will always be parallel to each other. So another way, so look at the green lines. Are the green lines parallel? The green lines are, so yes. So in looking at equations of horizontal and vertical lines, if it starts with the same letter and you're asked if it's parallel, the answer is yes. So pay attention to what I'm asking you, because if I'm asking you perpendicular, right, you have to know the difference. So for number 5, the answer was yes, they are parallel because they are both vertical. And I probably should have had both in the other ones too, right? It's both horizontal, both vertical. Okay. The last thing we're going to look at for the parallel lines is if we had a quadrilateral, and I'm going to go ahead and graph. A is -5, 3. I'll label that A. Let me make this a little bit thicker. Okay. All right. B is 2, 2. C is 4, -3. So you don't have to graph these necessarily, but graphing them makes it a little easier, I think, to see what you're working with. okay? So now we're wanting to know if we connected these, we would have a quadrilateral right here. That's what it's telling us. And to be a parallelogram, it would have to have two pair of parallel lines. Okay, so this is point A, point B, point C, and point D. So if you start by checking to see if line AD is parallel to BC. So AD. I will look at the coordinates for A and the coordinates for D to calculate slope. So I'm going to calculate the slope of that line. So 3 minus negative 2 over negative 5 minus negative 2. So in this case, I'll have 3 plus 2, which is 5, negative 5 plus 2, which is negative 3. For line BC is the other line that I would be testing to see if it's parallel. I would be looking at coordinates B and C. So 2 minus negative 3 and 2 minus 4. So I would get 2 plus 3 is 5, and 2 plus a negative 4 is going to be negative 2. If the slopes are not the same, which they are not, then no, this is not a parallelogram. Okay? One too many R's here. To be a parallelogram, they have to have two pairs of opposite parallel sides. So if I would have found that they were parallel, AD and BC, then I would go ahead and test AB and DC. But since these two are not parallel, the answer, it cannot be a parallelogram. You have to have two sets. Okay, the next concept about perpendicular lines, and you saw in the warm-up today, is that when the lines cross and form right angles, their slopes are going to be negative reciprocals of each other. We call that opposite reciprocals of each other. And you can see here it says the product of their slopes is negative 1. So looking at the example in your textbook, you calculate the slope of blue, red, and green just like we did for parallel. But this time we're looking for something different when we compare them. We're not looking to see if they're parallel. We don't care if they're the same. We're looking to see if they are negative reciprocals. So the blue line is negative 1/3. The red line is negative 2/7, and the green line is a positive 7/2. So because negative 2/7 and of red and the positive 7/2 of green are negative reciprocals of each other, their product is negative 1, the red and green are perpendicular. So we will do these. And so what we're going to do is calculate the slope of each line. So we'll start with the blue line. So the blue line, 3 minus negative 3 over 0 minus negative 1. We would have 3 plus 3, which is 6, and 0 plus 1, which is 1. For the red line, we could calculate and get 2 minus negative 3 and 4 minus 3. So 5 over 1. And finally, the green, we have negative 1 minus negative 2 over negative 4, minus 2, let me get that right. So we have negative 1 plus 2, which would be 1, and then we have negative 4 minus 2, which is like negative 4 plus negative 2, which is negative 6. So in this case, the blue line and the green line are perpendicular. They are negative reciprocals of each other. And to test that out, you could take 6 over 1 times a negative 1 over 6, and this is going to be equal to a negative 6 over 6 or negative 1. So we would say blue and green are perpendicular, and we just proved that the product of their slopes is -1, they are also negative reciprocals of each other. So on problem 2, the slope of the blue line is 1 minus -1 over 1 minus 5. So 2 over -4, or a -1/2. The red line is -2 minus -4 over -2 minus 2, or 2 over a -4, which also equals a -1/2. So red and blue are obviously parallel, but it's asking about perpendicular. And so looking at the green line, 2 minus the -4 over 3 minus 0 will have 6 over 3, which is a +2. So since a +2 is the negative or opposite reciprocal of the -1/2, red and blue are both perpendicular to green. So you would summarize that as red and blue, sorry about that, red and blue are both perpendicular to green. So then when you go to the next page, or the next example, and we're wanting to know if they're perpendicular, this is a little different. We're being asked to see if they're perpendicular. So now I want to know, are they going to cross each other? The only way they're going to cross each other is if one is vertical and one is horizontal. For number 9, the answer is yes. 1 vertical, the x equals -2, and 1 horizontal. Okay, for number 10, the answer is no. They are parallel, or they are both vertical, which makes them parallel. And number 11, yes, 1 horizontal, and of course you could also graph them, and 1 vertical. The last question, this is a parallelogram, and you could graph it. Then you're going to use slopes to determine if it's a rectangle. Then is it a rectangle, and justify your answer. So graphing this would be -5, 0, 1, 4, 3, 1, and -3, -3. So just by looking at it, we can't really tell, okay? But we're going to have to calculate the slopes of all of these. So we have J, K, L, and M. So on this problem, you're going to have to calculate the slope between like JM and KL, JK, and LM, because we're going to have to see if they are indeed perpendicular. To be perpendicular, they would be negative reciprocals of each other. Okay, so let's calculate the slope between J and K. So I would do, I'll label it JK so we know which line I'm doing. So we have 4 minus 0 over 1 minus the -5. Make sure that negative shows up. So 4 over 6. I can simplify this to 2/3. All right. For the line LM, I'll just do the line LM because it should be parallel to JK. LM would be 1 minus the -3, and that would be over change in x, which is 3 minus the -3. So 1 plus 3 is 4, 3 plus 3 is 6. It also simplifies to 2/3. So far, so good. And that was line LM. Okay. Then if I can test JM, and the coordinates are, for the change in y, 0 minus the negative 3, the change in x, negative 5 minus the negative 3, so we would have 3 over, in this case, negative 2. And finally, KL. KL is the last one I have to check. So the slope of KL is 4 minus 1 over 1 minus 3, so 3 over negative 2. JM, KL are also parallel. Now, when we look to compare and see if, say, JK and JM are perpendicular, we would want to take the slope of JK, which is 2 over 3, multiply to that 3 over negative 2, and the answer is going to be 6 over negative 6 or negative 1. Remember, the product of perpendicular lines are negative 1. So you can see 2/3 and 3 over negative 2 or negative 3/2 are negative or opposite reciprocals of each other. They are perpendicular, which makes this a rectangle. So you would want to write that it is a rectangle because the opposite parallel sides are perpendicular to the other sides.